Okay, welcome back to more stuff about lists. The lists just won't go away. We've got all next week as well. They just keep coming back. I've said before it's a rather important topic, because almost everything you get comes in the form of a list. For example, when we start to deal with a database system, because that's where most of the data is stored, you might go off and say, give me a list of students. Guess what form it comes back in? Yeah, it comes back as a list. Actually, it's probably a little more complicated. It's probably a list of dictionary objects, but we'll see that in a couple of weeks' time. Okay, so for right now, we're dealing with just what I call simple lists, and the only thing we're sticking inside lists at the moment are integers. We'll add some strings today. I think there might be an example of some booleans as well. And anyway, here we go. We've got some stuff called list operations and this rather bizarre little topic called mutability, which I unfortunately have to kind of mention because some of the data structures, when you try to deal with mutable or immutable objects, sometimes things act a little bit different. There's a few really important rules around here. Okay, so as usual, a set of sections from the textbook. Otherwise, it's probably more entertaining to take a look at some actual code. All right, so here we go. Then I'll bring back the code afterwards, make sure I haven't missed anything. All right, congratulations, we have ourselves a list. Okay, I mean, no, you haven't really solved that many problems using lists yet. Okay, we'll get there. Okay, but you saw last class how you could actually interact with the user and build up a list one piece at a time. I showed you how you could iterate through the elements of a list, and you could use that for solving certain things such as summation, finding the biggest, finding the smallest, and so on. Okay, and all of these things we'll cover in today's class, but we need sort of some technical things first, and then we can maybe start to put together like some real applications of things, because lists of integers on their own are not particularly exciting, but sometimes we still need to deal with this. But anyway, here we go. Let's. I don't really have really good complete examples, but that's all right. So, hey, I'm always dealing with just integers, so I thought today for this exercise we will use some strings. Okay, now I gotta figure out which one we're talking about. Okay, here we go. So let's add some strings to my list. So here we go. Here's Alice, Bob, and Charlie, typical Western names, A, B, and C. Here you go. This is not a big surprise. You print it out, you see exactly what's inside. Okay. We learned a few functions the other day, so I think it's probably worthwhile to go back and look at them again just to remind ourselves. The first function that I showed you was a function called length. Okay, and what it does is it tells you how many things are inside the list. So what are we expecting for the number of things in this list? 3. Yeah, that's exactly what it is. Okay, good news, it wasn't really a big surprise. All right, we also learned about a function called append. Now, you'll notice there's kind of a bit of a difference between this function and the one I just did. I'll come back and repeat that in a second. Okay, and who are we going to toss in here? I'll use the same names we've got. We've got Zoe, I guess. All right, so the append operation takes whatever you append in at the end and tacks it on to the end. So when you run this now, suddenly you have 4 names, and of course, well, the very last name was the one that you just put in. The word append means to put it at the very end. Okay, it doesn't go in alphabetical order. It doesn't matter if this was, if it started with A right here, it would still go at the end, okay, because that's where the appends always end up going. All right, that's fine. But just to remind you of something, we did see something that's a little bit different. You see length names. Okay, it's a different format. Notice that it's not names.length. It could have been. They decided not to do this. On line number 3, that's actually a function. Okay, and it works the same way, say the print function works the same way as the functions that you write. You call the function, you put a parentheses, and you pass in the values between the parentheses that you want the function to work on. Okay, so this is how you get the length. The append, on the other hand, is a little bit different. It's actually known as a method. Okay, now is that going to be a question on the test? No, but if you happen to be looking around online and somebody talks about methods and it kind of sounds it's almost like a function, yeah, they sort of are. So the idea is that you write the name of the thing that you're working with first, followed by a dot, followed by the operation you want to perform, followed by, well, whatever parameters are required for that particular method. Now, I will probably end up just calling these functions. I'll call everything a function, but just in case you see something online where somebody is saying that this is a method, yeah, that actually is a method. It's a list method. Okay? And we might see errors that appear. For example, if you try to call this method without passing anything, what do we get? Okay, luckily it just says that list.append takes only one argument. I was kind of worried it was going to say this list method takes only one argument. But if you look online, if you look at the slides, you'll even see the word method. Okay, so here we go. That was the first one. Okay, we don't care about this. I'm just interested in modifying things. So something that kind of looks suspicious is that, hey, these functions are not modifying things, and those methods are. No, unfortunately, there's no way that you can look at those and say, yes, this is how it works, because there's going to be lots of alternatives to it. So far, the append, yes, it does modify it. Length doesn't. Okay, if you ask for the length, you still have the same list afterwards. We're going to change all of this as we go through today. All right, next one up, that's probably of some use to us. Okay, and I call it some use because I'm telling you, we don't use them very often. Yeah.
On the length of the list, you got 3 characters. If you did the length again after an append, would it include that character, or would it? I'm not sure if I'm asking this question correctly.
You said something that's maybe a little bit incorrect, and we will fix this. Okay, it's not really bad, but it is kind of fundamentally, it has the wrong words. Okay, but in any case, I don't mind fixing this, so here we go. This was, here we go. Why not? But it's already there, yeah, it's fine. And we better print right here. Ooh, sorry. Let's set up enough of a problem. We'll make the prediction. And then we'll run it to see what happens. Okay, and if we get concerns, we'll just run it and we'll talk about it afterwards. All right, there are 4 print statements that I'm interested in. The one on line 5, that's just so I can tell what happened before and what happened afterwards. The before case. All right, pretty simple. On line number 2, that's going to print how many items are in my list. Okay, remember, it's not how many characters are in my list. Yeah. It's how many items. Okay, you said characters earlier, and remember, those are not characters. There are 3 items in the list. Yes. Okay, so it's not 3 characters, but 3 items. All right, and of course, if you print them out, well, you're going to see them. It's going to appear exactly as is. That's the nice thing about the print statement. It just shows it exactly as is. When we append a brand new person, okay, where does the new person go? At the end. Is there a problem because we already have somebody with the same name? And the answer is no. There's absolutely no restriction in lists. You can have the same number appearing over and over again. That's actually a good thing, because imagine if I was using a list to track, say, all of the test scores. Is it feasible that 2 people had the same score? And the answer is, of course it is. Okay, so yeah, there's no problem with this. After appending that new person on line number 6, and I ask how many items are in the list, how many items should we have? Yeah, we should have 4, and that's exactly what happens. So yes, that's exactly what I don't want to have happen. Go away. That's exactly what happens. Okay, so yes, the append does work exactly as expected, and yes, if you append something, then yes, you do get something new. Okay, so that's reasonable. All right, we have some other functions we have to talk about. Yeah, you know what? I'll leave the first few things up here so that I can deal with these other ones. Okay, same order, not the order of importance, but same order that we've got on the slides. Yeah. Why at the beginning it gave an error? Well, I'd have to go back and see what the error was. Okay, so is that a problem? No. Let me undo this one. I don't know at what point that error was showing up. Remember, the errors just stick there until I run it again. So I really don't know. Maybe I ran it like this. I just really don't know. Okay, so sorry, I can't. Excellent. Okay, class finished. No. Here we me a second. It's in here somewhere. Okay, that's one. That's the other one. Okay, here we go. So sorry, I don't know where I was. We could stop the recording, play it back, and see what the. But I think what it was left over from before. Okay, so I think that was all. Okay, now I've got to redo my work again. Okay, here we go. Print length of names. Okay, and we'll print to some of those just so I can separate it. So here we go. That's what we had. And I also need to figure out what we were trying to do. Okay, so I'll try again. I think it's like the 5th time I'm trying to get to the next operation. We'll never get there. Okay, here we go. Name dot, right, there's a function. The function's called remove. Take a wild guess what it does. It removes something. Okay, so let's give it a try. Yes. Names, thank you. Okay, we would have found that. We would have seen an error. And then we could say that was the error. It may have been something as simple as that. I may have just mistyped something. All right, and yeah, that does exactly what you expect it does. Okay, good. I mean, at least there are some things that make sense. And yeah, there are some things in programming that actually do make sense. It isn't all cryptic. There are sometimes some cryptic things, but this is definitely not one of them. I suppose what I'd better find out, however, is if I run this one, that's a question I have to ask. All right, the first time that I run it, there are 4 students in the class. Okay, we'll pretend there are 4 students. And if I remove Charlie, how many do I have left? Well, I still have 3. Oh, but I've got it showing up twice. Okay, so yes, there is the possibility that maybe doing this, it removes both of them. But again, that's not the way it works. What it will do is it will remove the first one. Now, this is important because a list is an ordered collection. So yes, there can be multiple ones, and it will remove the one that appears closer to the beginning of the list. When we get some unordered data structures, then you don't know which one it's going to take. Okay, well, others not going to work. Okay, but that's exactly what it does. So, hey, good. As I say, at least some things make a lot of sense. All right, this one here, this one, on the other hand, is perhaps a bit of a funny thing. Yeah, pop.
Can I remove both of them?
Sure, call it again.
Twice.
Yeah, call it twice, because you had 2 of them. Okay, that's actually an interesting thing. Okay, hey, problem solving. Yeah, let's do a problem solving. Ask me this question in a second. Okay, let me finish this because I'm still trying. Okay, and then I promise we'll solve it. Because then I'll have another function which will help. Okay, pop. Okay. Okay. So what exactly happens? Well, the easiest thing to do is let's try running it and see if we can make some sense about what might have happened. Okay, there's definitely something went away because there's one less.
Charlie.
Yeah, Charlie. Now, what I'm going to do is let me add a couple of extra people at the end. Okay, and okay, there we go. There's a couple of extra people, and let's run it this time. And I think now it might be a little clearer what it does. Yeah, it removes the very last item. Okay, good. Oh, because the append puts it there, and the pop can be used to get rid of it. Okay. In some languages, they actually use the name push to put something at the end and pop to remove it. Okay, here it's append and pop. I don't know. They could have used different names, but that's what you've got. All right, so, well, that's kind of a very useful thing. But you can actually do something a little bit different. Watch this one. Okay, you can pass in an optional argument.
That's what removed the first.
There we go. Let's clear this one. If you pass in a position, it'll actually remove the element at that position. So you're saying, please remove the thing at position number 0. Okay. In that case, could I just say -1? And the answer is yes. That, by the way, is the default parameter. So if you look at the pop function, you'll find that the position is by default -1. Yeah.
Can I say from 0 to 2?
No. No. Unfortunately, you can't. Well, I mean, you can try. You can say that because you just did, but it's not going to work in Python. There. What we can do is, let's take a look at what we've got. There are other things you can do. You can use list slicing to get rid of things. Okay, and that's an alternative. You use list slicing. We can even try solving that one. So here we go. Help.lists. Okay, will help that list. All right, so in case you ever forget, you're in the middle of a test and you can't remember what's the name of the function for doing this. I usually always provide like a little cheat sheet of things so you don't have to come back to here. But if we go down and we find, let's see, extend, copy, count, clear, append, we're looking for pop, there it is. So pop takes as a parameter the word self. Okay, remember what I said, things are a little bit different because you put the name in front. That's what the word self means, is put the name in front followed by a dot. The docs are not that nice. And it only takes as one, as a parameter, just the index. So unfortunately, even according to the documentation, no, you can't do it. Okay, if you're looking to get rid of things from here to here, list slicing is kind of the easiest way to deal with it. Okay, we can solve that one too. All right, yes, there are some other functions in here. Okay, sorry, there's one extra one that's on my slides, and I think we'll probably want it because of the request that was just made about getting rid of all of them. Okay, and here we go. What we will do, we are going to call, I'll just call it R. I hate using names like R, but we'll look at this next. All right, names, dot, and the operation is called count. It takes us a parameter, in this case a string because I've got a list full of strings. Okay, and guess what count does?
Counts how many.
Yeah, count, so this gives you the answer of 2. Okay, good, perfect. All right, let's use this to solve a problem then. Okay, here we go. Oh, actually, I've got kind of the cool little exercise right here. I might as well run this one, then we'll solve a small problem. Okay, here you go. So what does this do? Oh, sorry. If I run this, you're not going to see anything because, well, there's no print statement. Okay, if we stick a print statement and say count this, what are we expecting?
How many yeses?
Yeah, so we're expecting 3 of them.
3.
Okay, so it's a nice way to be able to count up the number of things that are there. Again, kind of useful. In this course, how many of these do we use on a regular basis? Append. That's the one we're going to use the most. Okay, will we ever write programs that need the others? No. Sorry, it's that limited in use. Will you say MCQ questions using the other ones? Yes. Okay, and you can probably even count how many times they. No. No, but be honest, they show up as MCQ questions because you usually want to know, does somebody know that a pop actually does? It removes a position not by given a value. Like if you said pop Charlie before, that's going to blow up because there's no position called Charlie. As opposed to remove Charlie. So those types of questions do show up. All right, let's write a small program. All right, so here we go. We'll try to cover 2 questions that have popped up. Let's deal with the first one. So how about this? You have a list of test scores. Get rid of all the 59 scores because you just don't want them. I don't mean change them. I just mean get rid of them because they're always trouble. Okay, trust me. If you have any 59s as a final grade, you'll have trouble. People will come and complain and saying, yeah, but it's only 1 mark away. So yeah, we just get rid of them. So I'm not talking about scaling them up. I'm just get rid of the students together. Oh, okay, here we go. So final scores. All right, so we need a bunch of test scores. I should have asked ChatGPT to do this. Okay, there's one bad one we're going to have some trouble with. Here's another bad one. Okay, here's another bad one. And let's see, this, here's another bad one, and so on. All right, to make this fit on the screen so I can see it, I'm going to press an enter key right here. That, of course, we know is completely allowed. Normally, I'd probably make it balanced, but whatever. All right, so I want to get rid of all the 59s. Okay, so we know that we can call remove to get rid of them. Okay, so here we go. If we simply say final scores dot remove 59, and if I print final scores, it didn't quite get rid of all of them because there's many more. Yeah, it only gets rid of 1, so you just put it in a loop and you repeat it. How many times?
3.
Well, 3 because there's 3 this time. Okay, but how do you know there's 3? Yeah, you counted. Okay, excellent. So let's call them problems. Okay, and I'm going to go to the final scores and I'm going to say count all the 59s. There you go. Go and count them. And I'm going to set this up as a loop. For I in range. I'm going to talk about that in a second because it was something I wanted to cover. Problems. Okay, remove 59. Okay, there you go. So you run this one and, that's a problem. That's a syntax problem. Okay, sorry, try that again. There we go. All the 59s are gone because I counted them in advance. That's the easiest way. The cool thing about count is everything else is left in the same order. So if order is important, at least the order is preserved. Okay, maybe that'll be something we want to change later, but there you go. That's the way how I could solve this. All right, the second problem somebody wanted to get rid of. Okay, you have a list of test scores. Let's get rid of the scores in positions. Okay, now you were talking about removing multiple things, like a pop, 3 through 6 inclusive. Okay, and we better come up with what that means. Final scores, I think it'll make it easier to see. All right, so we're talking about getting rid of stuff that begins in position number 3. So there you go, that's position number 3. 4, 5, and 6. So we're asking to get rid of these things. Okay, yeah.
Is in position number 3.
0, 1, 2, 3.
Yeah.
Yeah, it starts from 0. So, I mean, it certainly ask me because sometimes I'll highlight the wrong thing. And not always on
I
purpose.
just messed up sometimes.
Yep, that's okay. Everybody does. All right, so there we go. We're talking about getting rid of these things. Now, if I know I have to get rid of 4 things, okay, could we just do the same type of approach that we did a few seconds ago? What if we just set it up in a loop for, I forgot to cover something, for I in range. Now, how many things are we trying to get rid of? We're trying to get rid of 4 things. Okay, so 3, 4, 5, and 6. Well, we have the option here. You can say finals scores dot pop at position number 3. You see, because once you call it once, everything will shift to the right, or sorry, to the left, and then you'll have one less, and you're going to do it again and again and again. So there you go. That's one way of getting rid of it. Okay, yeah, repeated pop. Okay, can you do it in 1? No. No, you won't be able to do it in 1. Sorry, I've got this one weird little problem right here. It's kind of annoying. It won't happen very often, but is that allowed? And the answer is no. Okay. You always need to have a variable. It's called the for loop counter variable. I've been using I. Sometimes people use the word counter, and that's completely fine. By the way, if you do this, you're not going to lose any marks on any tests. But there is kind of a standard thing, because you see, we're not actually using the word counter for anything. Okay, so often what people will do who write Python programs, just as a placeholder, again, you don't have to do this, but in case you see something online, they will use this as a variable. It's a single underscore. And all that is just like, yeah, it's a variable, but we're not really using it. Okay? You don't have to follow this. Okay, there's just no requirement for it. You're not going to lose marks, but you do obviously need to have a variable there. And an underscore by itself is a valid variable name. It'd be a really terrible variable name, but you're allowed to have it. Like, for example, instead of final scores, I could use that. Of course, it's not going to be very easy to read. It's much easier when you look at that, but hey, it is possible. And you know, this will work fine. Okay, there you go. There's one solution. The next one, I talked about list slicing. Okay, let's give it a shot so we get some ideas. Because I did talk about list slicing the other day. Now, here's the thing is, if I'm looking to get rid of from position 3 until 6, I'm going to have 2 parts. I'm going to have something called first, and I'm going to go to final scores. And remember, slicing works like this. You say where you're going to start, and you go to the point where you're going to end, but not including. So it would be from 0 to 3. Okay, and print first. There you go. There's the first 3 things. All right. Most people, well, again, a little lazy, they probably leave the 0 out. Okay, and that still gives you exactly the same thing. That's the first part. All right. There's also the second part. Okay, so I'll call it second. You go to final scores and, okay, if you start from 6 and you go to the end, is that the right one? Okay, well, let's just make sure this is going to work first, and then we'll check and see if we've got the right things. All right, so we were supposed to remove 3, 4, 5, and 6. Whoops, had too many things. Yeah, so it's one extra, of course. So you wanted to get rid of number 6, it's inclusive, so you'd have to start at 7. Or you could write it as 6 plus 1 to remind you. All right, that's great. That gets rid of the things. However, now I have 2 lists. And if everything needs to be together in one list, it's going to require something that we haven't seen yet. But I think if I turn the page several times, I find it. So I might as well cover this one now and then it's out of the way. All right, if you have 2 lists and you want to put them together, you have 2 mechanisms for doing it. Yes? From 0 to 3, but not including 3. Yeah, position 0, position 1, and position 2. Okay, yeah, so remember, this is position 0, this is 1, this is 2. So I wanted to remove from 3 to 6. I wanted those to go away. Okay, yeah, it's the usual thing, starts from 0. Okay, everybody will mess up. Same deal as with strings. Okay, so we have something called first and second, which happens to contain exactly what we want, but now we have to put it together into a single list. All right, the good news is it is very straightforward. What I could do is I could go back to final scores and I could take the first and I can add the second. And what this does, wrong editor, final scores, that's called list concatenation. Oh, just like string concatenation. And it does exactly what you think it does, which is it takes the first part and then tacks on the rest of the items from the next. Okay, that's it. There's a small alternative to this in case you wanted it. And that is what I've done. Of course, I put it back in the final scores, so the original final scores is gone. There's a slightly different way of solving this same problem. If you go to first, there's another method that shows up. It's like 3 or 4 slides ahead. The function is called extend. And what you do is you provide the second, and if I now print first, what it will do is exactly the same thing. It takes the list called first, and it adds each of the items from second to the end. Basically, it does it as a pile of appends. Okay, and that's it. So yeah, so in order to remove some stuff from a range, you have those 2 options. Either repeatedly delete something or use slicing to recreate the new thing with the thing that you don't want. Is there one that's better than the other in terms of how fast it works? No, they're both pretty bad. I would say that the list slicing is probably even a little bit worse for performance-wise, but the first approach that I used for the list slicing plus the concatenation, this is exactly what all Python programmers would do. Okay, it's the most natural thing. Use the slice to pull out the stuff at the beginning, the stuff at the end, jam it back together with a concatenation. Okay, so cool question for both of those. Okay, so here you go. That's the common list methods. So those are the ones that are built in. These are, again, the most common things that I end up pushing around in the course because they're pretty obvious. The only thing that's a little bit bizarre out of this, of course, is, the insert position item. Sorry, we have to go back and we have to look at the insert position item because we didn't try enough stuff yet. And it's always the weird things that will get you into trouble in this place. Okay, final scores insert. Insert takes 2 parameters. The first thing is the position, the second thing is the value. Let me print final scores. All right, when I print this, where does the 99 appear? Or does it even work? You think everybody's just waiting for me to run it? Okay, does it work or not? Okay, so you think it does. And if it does work, which I think it does, where will the 99 go? In position 0. And by doing an insert, what we're talking about is we're talking about pushing everything else forward. Okay, that's very, very different than, say, final scores at 0 is equal to 99. That's very different because that changes the item that's in position 0. This actually causes a new item to be put at position 0. All right, so now I have to start asking some questions. What happens if I put the position at 3? Oh, sorry, let's do something easy, 2. If I print this, what are we going to see? Well, the 56 and the 78 are still the same. And then what comes next? The 99, because that's where we inserted it. And of course, 100 at the end. Okay, and that's exactly it. All right, so next one is, what if I stick here 3?
No, still not there.
Yeah, it sounds like it should go at the end. That seems certainly convenient. All right, and here we go. And what happens if I try putting it in at number 4?
Out of bounds.
Yeah, that seems like a pretty reasonable thing and out of bounds. Let's see. Let's clear the output and we'll run it. And instead, no, it just stuck it at the end.
Okay.
Oh, okay. Let's try putting it at position 400. And exactly the same unfortunate result. Okay, so it's good the program doesn't crash. The bad news is I probably wanted it to crash. Unfortunately, this is the way how Python works. There are lots of weird languages. In a lot of languages, an operation like that would fail and would say, yeah, out of bounds, exactly as expected. There are other languages like JavaScript. If you carry on to do WebTech 2, you do this, what will happen is suddenly your array will have 400 items because it automatically resizes. Yeah.
Why does 400
Because remember what this means, it says put the value 99 into position 400. I'm not putting 400 into the list, I'm putting 99 in the list at position 400. Okay, that's why we don't see 400. Okay, otherwise, as I say, these are the really important ones. Are they ever required? Okay, I told you as you went through, there's some that I think are really important. Append, you better stick that in your mind because all the programming is going to be about append. What about these other ones? Okay, maybe you'll mess up in an MCQ. The MCQs are not going to pass or fail you in this course. It's the programming exercises. Do we use insert often? No. Remove often? No. Pop? No. Count? Maybe occasionally, but really the append is the most important one, and you'll see me use it all the time. The length of the array and the append. Okay, what do we got next? Okay, what does the word mutable mean? Because that was a word that showed up. We kind of talked about this in the previous class where I said that a list is mutable because you can modify the values inside the list without having to throw the entire list out and make a brand new one. Kind of like what we have to do with the world of strings. Strings, on the other hand, are not mutable, but you can actually create things. So let me do something because this question actually popped up a little while ago. Okay, so here we go. The course name is usually what I use for string manipulation, infs1201, Introduction to Python. Oh, whoops. I made a mistake. It's 1202. The new improved version of 12, no. Okay, can I change an individual character to say 1201 instead? And the answer is yes, I can, but it's not like this. Because you might be tempted to say, hey, if I can get at position 0, 1, 2, 3, 4, 5, 6, 7, if I get in here in the position number 7, and I can change that to be the number 1 and print the course name, that would be great, but unfortunately we're not allowed to do this. Okay, so we're completely out of chance for this. Okay, fine. I just showed you a technique for doing something. Oh, a dot insert, almost. It's going to be almost the same idea. See, I'm going to take the course name, and I'm going to go only up to position 7. Okay, that gives me this much. And what I'm going to do is I'm going to tag on course name from position 8 to the end. Okay, and what do I get? Well, I get everything except for that one thing.
Yeah.
Okay, so in other words, it's a way that I got rid of something. Did I actually change the string? No, what I did is I made a brand new string. Okay, that's the difference between something that's mutable versus immutable. And if you need a 1 to go in the middle, that's what you'd have to do. Okay. An array, on the other hand, sorry, a list, on the other hand, you can just go to the one location and change it. You don't need to pull it apart and stick them back together. It's kind of inefficient. All right, so here we go. The word mutable means that you can change things, so strings are not mutable. You can make a new string, but strangely enough, integers and floats are also not immutable. This is unfortunately, okay, I'm going to do one quick little demonstration of something. Don't worry, it's not part of the course. I'm not going to ask you to explain this one later. The only reason why I include this is because whenever you read stuff about the higher data structures, it's going to be talking about mutable and immutable objects. Okay, so I just have to cover it. It will become really important in the next thing when I talk about aliasing. So this is just my very, very quick attempt to do something. This may fail really miserably. All right, it's not a trick question, okay? All right, I have two, sorry, how many variables do I have? Two, very good. Are they the same variable? Of course they're not the same variable. They're two different variables. One's called X, one's called Y. How do we know it's two different variables? Well, we don't. That's just what you were told. Okay, there's a function called ID. What it will do, it doesn't print, so when I print the ID of X, it won't print the value of X, but it'll print the memory location of X. Okay, so you get back a number. It's completely meaningless to us because it's only used by Python internally. But what I want to do is I want to print the ID of Y as well. And guess what's going to happen? So I'm going to print the memory location of X and the memory location of Y. Are they the same? And the answer is no, they're not. So as a result, they have two different memory locations. Very good. Now, this is something completely weird. Okay, I have how many variables do I have? I still have two variables. I have X and Y. What are their values? 34. Are they the same memory are they the same variable? No, but guess what? They're the same memory location. It's an optimization that Python does. I really don't understand it, but they've actually layered it over top of each other to save memory. I don't know how they justify doing this. It's really, really strange. But here we go. This is one way how I can prove that you have a different memory location for something. All right, now, to put this into context what we're trying to talk about. So here we go. X is equal to 34, print the ID of X, and X is now equal to 99, print the ID of X. You notice something about this? They're two different memory locations. It's because integers in Python are not mutable, so that when you try to assign something, it makes a brand new integer in a different location. Kind of inefficient. Most other programming languages don't do this. All right, so there you go. We just have to check the ID. We're only going to use this occasionally just to say that, hey, it's the same or not. Okay, let me change this up a little bit. X is now a list. X at position 0 is now changed. Okay, here we go. My question is, when I run this program, is the memory location the same? And the answer is yes, it is. Because it's a list and it's mutable, Python's able to change it without creating a new object. Okay, that's all that it means. Okay.
So
Well,
it's mutable, it changes the memory location.
if it's mutable, it will get a brand new memory location, yes. Okay, that's it. Now this has a little bit of a side effect. Don't worry, I will never come back and ask anything about the ID function on any tests or any other assessments. This is just as a quick demonstration to show that, yeah, if you have a list, you can change the list. Hey, here we go, x.append. Okay, we know that x.append will add a brand new thing, but guess what? It's still the same list. Okay, so the list is changing, but it's not a brand new list. That's the word mutable. Okay, now this has one and only one result. I can never get my slides back here again. Here we go, continue. I guess I hit the wrong button. All right, so so don't worry about most of these. The effect of mutability. When you start to deal with mutable objects, a lot of really weird things start to happen. Okay, and now what we have to do is, this unfortunately will be necessary. All right, I have a variable called X. Okay, well, you know what? Let's call them test scores. Oh, okay, I guess those are not test scores anybody wants to see. All right, so there we go. Ooh, not very good, that's fine. All right, so we have test scores. Okay, excellent. All right, we're going to do a small exercise. Okay, I'm going to print the test scores. Bang. I am going to go through all of the test scores and I'm going to fix them. Should I do that? Yeah, no. I don't want to fix them. What I'm going to do is I'm going to say final scores is equal to test scores. And I'm going to print the final scores. Okay, I think everybody will understand this one. There you go, there's the final scores. All right, so we have the original test scores, and on line number 4, it looks like what we've done is we've taken all of those test scores and we put it inside final scores. And what I want to do is I would like to go through each of the final scores, and I'm going to fix the low ones. Like I'll fix the 45, we'll make it 60. Here's what I'm going to do. I'm going to say for index in range length final scores, I'm using an index range so that I can modify it. If I don't have to modify it, I would just hit for scores in final scores. All right, here's what I'm going to do. I'm going to say if final scores at index is less than 60, I'm going to change it to say final scores at index is exactly equal to 60. Okay, so that's the super one that everybody wants. Okay, is it clear what I'm doing here? Okay, we have to check it, and we have to find out, does it work? Okay, so did it work? Did it fix all those bad scores? Excellent. My real question becomes, what's test scores? I mean, we didn't change that, right? So that should still be the original test scores. So I should see 2 outputs. I should see the one where I've corrected the low scores, and I should see the second one with the originals. But unfortunately, when you run this, you get some really weird behavior. And it looks like the test scores was also modified. And that's exactly what happened. All right, the reason why it happened, I can prove it pretty simple down here. Here we go. Let me print double. Let me print the memory location of final scores and print the memory location of test scores. And take a look at the memory location. It's the same. Okay, here's, in the world of Python, lists are treated very, very differently when you use the assignment operator because they're mutable. In order to make things faster, Python doesn't make an actual copy of the list. It simply has 2 references that said, okay, this is final scores and this is test scores, but they're both pointing to the same location. So if you're changing one, you're really changing the other. Right? That one is kind of a big surprise, but unfortunately, it ends up happening. So this is a bit of an issue. If you don't want this to happen, you've got to do a couple of things. Okay, I'm going to do this first, which is kind of like skipping forward a slide, but that's fine. Then we'll come back. If you really want to make a copy of test scores and put it into final scores, you have 2 options for doing it. The first is a method called copy. Okay, and this works the way that you think it should work. Okay, so you'll see that the very first print of the final scores, yeah, that has the adjusted scores. The second one was the test scores, but you'll see that the 45 was never modified because, well, instead of working on the same list, I'm now working on a copy. And that becomes very clear when I print the memory location. It was 2 different lists. Okay, so in other words, you can't just use an assignment statement to make a copy of a list. You can do it with integers, you can do it with any immutable object, but any mutable object, like a list, eventually we'll see a set, a tuple. Okay, tuples are kind of weird. And dictionaries, those things are mutable, and if you actually want to make a copy, there's a function called copy, and you have to use it. There's an alternative. If you don't like so much typing, you can use list slicing, and that will do exactly the same thing. So what is that? That says, well, get a copy of the elements starting from the beginning and go right to the end. Okay. This works exactly the same way. Clear the output, here you go. Exactly the same thing as a dot copy. So if you ever need to make a copy, one of those 2 things will give it to you. All right, so it gets worse yet. Okay, here we go. Let's write a function. Okay, let's write a function to do something. with my test scores. So pretend we didn't see anything about aliasing. Let's have a function, because that's what we're supposed to be writing, and I'm going to call it fixed grades. Okay, so what's going to happen is I'm going to get a bunch of scores passed in, and I need to fix them. Okay, now what does it mean to fix them? Well, exactly the same thing. So watch this. I'll use the same thing for index in range length scores, and I'll ask the same question. There we go. If the scores at index is less than, here, let's make it 70. So yeah, we'll change it for 70. That's fine. Then we'll say that scores at index is now set equal to 70. All right, so there we go. There's a function that goes through and does something. Now, let me call the function fix grades test scores. Before starting, I'm going to print the test scores. Okay, and after, I'm going to print the test scores. And I'm going to ask a couple of things because this is starting to go against some of the stuff that we learned a little while ago. When we covered functions, I said if you want to pass something into a function, it goes in as parameters, and if you want something back, it comes as a return. Okay, am I returning anything? And the answer is no, so it sounds like I'm doing some bad stuff. Okay, yeah, fair enough. We'll fix it. Second thing that I would have taught you about variable scoping is if you pass something in as a parameter and the function changes the value, does that have any impact outside? And the answer is of course not. Okay, let me run the program. You see, it's actually modified it. And it kind of goes against some of the stuff that we covered earlier. First of all, there's no return. How does it getting it back? A second thing is when I passed in test scores, it came up here as scores, but it actually modified it. So yes, when you pass in mutable objects, you can actually change them directly inside the function. And that can be sometimes a bit of a surprise. So what I was able to do was I was able to get data back from the function without a return. Why did they do this? All right, the real reason for it is when you pass in big structures like lists, it's actually pretty slow to copy. So what Python did was it said, well, obviously the programmers know what they're trying to do. Therefore, we're going to pass it in by what's called reference. And scores is going to be exactly the same address as test scores. So if you're modifying scores, you're really modifying test scores. Okay, little inconsistency. Right. This obviously comes with a side effect, but unfortunately, it's something we do quite often. So quite often we do have these functions where you will pass something in and you'll say, please modify it. Your doc string that you write here has to actually say that, hey, yes, we are actually modifying. So we might say modify scores so that the blah, 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 so that the scores less than 70 are set up to 70. Yeah, this is what the whole purpose of a comment is, to warn the person saying, hey, yes, you can call this function, but watch out, it doesn't return anything, and instead, it actually modifies things. So if you say, well, how about this? What if we return it instead? Okay. Return scores. All right, so here we go, fixed grades, and these will be final adjusted. And if you print final adjusted, okay, let's go ahead and run it. Final adjusted.
Yeah, the last.
Oh, whatever it is, I don't care as long as it's spelled the same, right?
Yeah.
Okay, it could be W. All right, but here we go. So this one, yes, it works, right? So I pass it in, I got back the answer. Unfortunately, if you do one final print test scores, guess what happened? Is it the original or is it changed? Yeah, it's changed because it passed in as an alias. Yeah, you just have to watch out for this. If you don't trust the function, here's what you do. Pass in a copy. Because now scores inside the function will be its own little copy and nobody can mess with it. And quite again, what people will do is they will probably use this notation. Okay, so if you ever need a copy, then just make a copy. Just keep this in mind. You have to know what's going on. Sometimes I will ask you to not change it. Sometimes I will ask you to change it. Okay, so can I do it without this? And the answer is yes. I could make a brand new result, and I could build up a brand new result. Okay, that would be another approach. So let's do this one as well. I would often do something like this. You may say, let's have a brand new result called result. And what I'm going to do is, if it's bigger, less than 70, I'm going to say result.append 70. Otherwise, I'm going to result.append, let's see, scores at index. Okay, and I'm going to return result. There's an alternative version, and that's the way that I would probably do it. Okay? So we're not actually modifying test scores. We're simply iterating through test scores, and we're building a brand new list with our own values. And now we don't have an alias anymore. It's just things you have to watch out for. So these are the things that will sometimes get you into trouble. The good news is in this course, I'm usually very careful on the assessments where I say, look, write the function so it does exactly this. If I ever say, make sure that scores is not modified, you better make sure the scores is not modified. In other words, you better make a brand new list. Okay? I'm not going to say make a brand new list. I'm just going to say make sure the parameter is not modified. Other times I'm going to say call this function and modify the existing scores, but don't return anything. Okay, just follow the instructions. Okay, let's get back over to here. Okay, we're almost done. Then we can finally run that Kahoot because at least now we've seen aliasing. Okay, so the effects of mutability. Okay, so yes, mutability problems, you get aliasing if you use an assignment operator, or if you call and you pass something in as a parameter. If you want to avoid that, then you either use a .copy or you use that weird list slicing, which also produces a copy. Okay, so we've done all of that. List concatenation, excellent. We've already covered it. Okay, and I think I've got one extra slide. Actually, it says I got quite a few slides. Oh, I'm going to be a few more minutes. Sorry, yeah, we'll be long this time. All right, so if you use append with a list inside, sometimes students try doing this, you'll actually append the list at the end and you'll end up with a nested list, not something that you want. Okay, so just keep in mind, append takes one value, extend takes two things. Okay, built-in functions for numerical values. Okay, excellent. Let's get into here and let's do a little bit of work. Here's the test scores. All right, there's going to be lots of times where you will want something. Parent, nice. All right, how do you add up everything? Okay, if I ask you to add up all these test scores, what do? You have a total, you set it equal to 0. You go through each item and you keep adding it every time. So you'd say total is equal to 0. You'd say for S for test score in test scores. And you'd say that total is equal to total plus S. All right, and print total at the end. Bang, there you go, 333. I'll trust that it is. Okay, it probably is correct. All right, so that's one way. Because you're constantly adding things up over and over and over again, people have come up with better ways or quicker ways of dealing with things. And you may have seen me type the word sum at one point, and I said, ooh, should we be using that as a variable? And the answer is no, because it's purple. That's because it's a built-in function. And one of the things that it knows how to do is it knows how to add up all the values in a list. Well, that's easy. All right, so we got the thing called sum. We've got a couple of other ones that are very, very useful. For example, there's one called max. Yeah, it'll give me the maximum, so this one is the 80. Okay, so yeah, it's the biggest number. All right, and the equivalent one that goes along with it is, what's the smallest? All right, so those are cool. Can we use them on a test? Absolutely. However, the test question will never be, here's a list of integers, find the biggest. Okay, it doesn't happen. I may give you some other things such as, here is a list of test scores, find the smallest passing mark, because then you can't use the function, right? Because what's the smallest passing mark here? Well, it's a 60 right now. Okay, so how are you going to figure that out? Well, okay, 69, 67, we'll put a couple of others in here just we got some bigger stuff. Here's another 80, here's another 90. How would you solve this problem? Well, there's a couple of different ways how you can solve it. You know what, I might as well show you how to deal with these, even regardless of whatever's coming in the slides next. So, hey, I like to do things out of order. So let's solve this problem. Let's do this. Find the lowest passing grade. Okay, so what's the lowest passing grade? 67. Okay, so we need to find some way of getting there. Now, notice that I can't just go looking for 67. Okay, because we don't know what the lowest grade is. I can't call min, because if I call min, I'm going to get 45. Okay, and obviously max is not going to be any good either. All right, so how do we solve this problem? Well, you could use the technique that we've learned before where you take the very first value and you're looking for the smallest. Okay, you start smallest with a really big number, you find something smaller, then you make it smaller. Okay, you know what, I'm going to do all of these. So here we go. The smallest. Okay, smallest score so far is a really big number. That I can get away with because there's nobody's got a grade this high. What I'm going to do is I'm going to go through each of the items for S in test score. Okay, let's call it score in test scores. Let's see if we can come up with this. All right, here's what I'm going to ask. If score is less than smallest, normally what I would do is I would say that the smallest is equal to score, and I'm just going to print the smallest at the end. There you go. So that's the 45, not the number I'm looking for because I want the smallest thing. I could do this with an AND. Okay, so here's what I'm going to do. I'm going to stick an extra condition in here. I'm going to say if the score is bigger than or equal to 60 and the score is smaller than the smallest, then I'm going to count it. Okay, there you go. That's one way. Okay, that is what I would call using logic to solve the problem, and that's completely fine. People that work a lot with lists would probably do something like this. Okay, those are the passing grades. You'll see me do this all the time. Okay, print passing grades. Okay, see what I did? I went through and I got rid of all the failing grades because I wasn't interested in them. I rebuilt a brand new list with only the things that had 60 or bigger. All right, because if I have only passing grades, now I can just ask for the smallest. And there you go. All right, so yeah, use these techniques to build up lists of exactly the things that you need. We're going to see this happen over and over and over again. So you don't get to use the min function directly, but you reconsider the problem and say, well, if I didn't have these other ones, get rid of them, then I can use it. And the same thing if you wanted the sum of all the passing grades or the average of the passing. Yeah.
If I had the same problem at the exam and I used something we didn't take, is it okay?
What are you going to use that you didn't take?
Like filter?
No. We're not using those. We're not using list comprehensions either in this course. Okay, so if you know how to deal with these other things, don't use them. Okay, when in doubt, ask the instructor. Okay, but generally in this course, no. Those filter functions and so on, all the built-in stuff, they're really cool. It's really good for shortcuts, but sorry, you're not in a position to be dealing with shortcuts in 1201. Okay, after you're finished learning how to program, that's fine, because what I've seen occasionally is I get students who can use these really cool techniques, but they can't solve basic logic problems, and you need practice on logic problems. That's the general overall, okay? My usual comment in most of my other courses is anything that's outside the scope of the course, fine, once you finish my course, I don't care what you do. Okay, but for now, something different. All right, I've got a little bit of an interesting problem here. I guess I'll have to type it. There we go, words. Okay, words. Cherry, apple, Okay, here we go, and banana. Okay, and potato. Yeah, things that we don't have in common. All right, fine, so something a little bit different. All right, that is a list. Okay, here we go. Length of words. What do I get? 4. Yeah, there's four words. That's fine. We got some other functions. Min. Okay, this is one that actually does work. What does it mean to have min words? What's the smallest word? And you might look at that and say, okay, what does it mean to be the smallest? You mean the smallest number of characters? No, not the smallest number of characters, but if you were to put this in alphabetical order, which one would show up first? And apple shows up before anything else. If you were to ask for the maximum, okay, what's the maximum?
The one that would show up last.
Okay, and what is in this case? This will be potato. Okay, and if there's some zucchini in this mix, okay, sort of, I should have called this like a pie or something, dessert. Okay, if you had zucchini in your dessert, maybe it won't be great, but yes, it would show up as the maximum. Okay, cool. And if that's the case, how about this? What do you get if you sum all the words? Cherry, apple, banana, potato. Pen. I should have put in the words pen, pineapple, apple, pen, right? Okay. No, if you run this, yeah, you can't do this.
Yeah.
Okay, so it says you can't.
Yes.
Even though you can use plus with strings, sorry, the sum operation doesn't work. Okay, let's see. We're almost there. We're almost there. Using. Okay, I've kind of done that already. Yeah. Yes. Because cherry is not the smallest word because apple came before it. No, not about the position. It's about the alphabetical order. If you were to sort this in the same order that things would show up in the dictionary, which word would come first in the dictionary? Apple. Okay. And which one comes at the end? Potato, because that happens to be the biggest. If I remove potato, max would be cherry, because it would show up at the most. Okay, so using built-in functions. Okay, so yes, you can certainly use it, and if you're allowed to use it, then why learn the algorithms? Because when we get into the complicated data structures, you're going to need them. Okay, because it's not going to be a simple, oh, I just have to do this and it works. No, as I said, I will never ask you, hey, please write a function that calculates the sum of these numbers. No, because I know it's just a single line sum. That's not the type of thing we're testing on. You might have to filter things through first yourself, and then of course you can put it into a format that you can use, and we use that a few times. And I've just reminded you what the algorithms actually look like. So the summation, you start something at the total, you go through and add. If you're looking for the largest element, you normally pick the very first element, and then if you find something bigger, well, that becomes the largest. We've done this a bunch of times. And this one right here, this is a very useful technique. So let me pull this one out as an example. I'm not saying it's a good idea, but just because things aren't good ideas doesn't mean that they don't appear sometimes inside this course. All right, every now and then somebody will come up with a problem for a test that will involve what I call mixed data. Okay, so what I've got up here is I've got a list. Okay, well, first thing I'm going to ask is it allowed? Can I have a mixture of things? And the answer is yes, you can. Okay, I'm not saying it's a good idea, I'm just saying you can. And how many items are inside my mixed list? Yeah, there's 8 of them. Okay, yeah, there's 4 in the first line, 4 in the second line. Okay, so that's fine. But the issue is if somebody says, please go through and add up all the numbers. So let's suppose that the first word is a description of something, the second one is the quantity of something, or maybe it's the price of some item. If you wanted to add up all of these, obviously you can't just do something like a sum of mixed data, because if you try that, because there's strings in the middle. So we have a couple of ways how to deal with this, and I remember seeing this on a test once. Some students did this, and it was allowable. In range of length of mixed data, you see all of the items that are values happen to show up in odd positions. Okay, total is equal to 0. And then at the very end, total. There you go. So that's one way of doing it. Okay, and it's perfectly fine to do it this way. Somebody who will think about this a little bit more, and again, if you go through a lot of practice, somebody may look at this and go say, hey, it's every other thing. Okay, well, if you remember, I mean, we did this in labs with strings. Let's see, values, mixed data. Okay, here we go. Remember what the final colon does? Yeah, it actually gets every other thing. So if I say values, of course it'll come back. Oh, that's not what I want. Those are the names. But if I start at position 1 and pull everything out, well, that's exactly the values. Now, of course, I can use sum. Okay, but it requires the practice that we've been through these things. Okay, so that's why I always say it's a pile of practice you need to go through. Okay, so very quickly over the last few, and okay, I think now we're probably okay to run that Kahoot that I tried last time. So this one is about lists, and I know that the very beginning had some stuff about lists, about aliasing and so on. That's why I had to stop it last time, but I think based on today, we should have enough to be able to do it. Okay, so here we go. I've heard weird, funky music. Maybe that's for the better. Storage audio. Sound. There we go. It's so weird to do it complete silence. I don't like it. It's just too awkward for me to stand here not saying anything. Okay, so I can see that our variable naming convention is getting worse as we're going. Very good. You're becoming more and more like programmers. Capitals, however, you're supposed to avoid. That's the first letter because that really means something different. Okay, is that all? 15? Anybody else? Ah, well, that's just the internet. Soon the internet will be like the doors and it will shut down after 2 seconds of inoperable use. And you'll have to put in a request to gain access to it. Okay, it's flopping around. Okay, so we'll go with this one. Okay, so let's see. So you might even remember the question from yesterday or previous class. Hopefully it's the same set I've given you. Now, this would be like the creepy music would be kind of cool to do during final exams. Okay, everybody's done, and so are we. Ooh, okay, well, I mean, unfortunately, the biggest number of people ended up going for the wrong one again. You're not supposed to be doing this. At least a bunch of people did have the right one. All right, so let's find out what happened here. Okay, so 2, 4, and 6 was a very likely thing, and of course, well, you saw that you called the list, but remember, when you call a function with a list, you get an alias, and whatever you do to the list inside the function, you're really doing to the list outside. I mean, we just did that. So we have to unfortunately come in here. Now, if I had put weird looking, well, it looks like a weird robot smiley face. That's the list slicing as the copy or dot copy. It becomes a really trivial problem and you simply ignore whatever's going on. But otherwise, it's adding 3 and it's multiplying by 3. So yes, it is modifying this one and this. So yeah, we're expecting this one. Okay. Hey, I only got 20 seconds for this? Well, it's pretty obvious, isn't it? Okay, so one person got it correct. Okay, very good. And everybody else got a 10. Please note, yeah, those quotation marks, that means string.
Oh.
And unfortunately, even if they're integers, I think I said this once before in this lecture even, unfortunately what happens is it looks at the very first character
Yeah.
of a string. So the 4 is actually bigger than the 1. So that's why it
then
shows up.
would be the 2 comes before the 4.
And no, the 2 would be before the 4. Okay, so if you were to sort this, you'd have you'd have a 10 followed by a 2 followed by a 4. Okay, strings completely different, so watch out for this one. This gets people all the time. If you have a D2L course shell and your instructor has said lab 01, lab 02, lab 03, they've done this to keep everything in order. Okay, because strings are sorted in a completely weird way. Okay, so I know it happens. Okay, and don't worry, it happens every semester. Is why this question is here. Okay, I see there's a little typo here. I mean, if this is the right answer, pretend that there's a square bracket at the end. I fixed that one. Anyway, I'll say the same thing again next time. Okay, good. Okay, so we learned from the first time that, yeah, list aliasing happens, so very good. At that point, really the only irritating point is I made you go through a loop a bunch of times and check if something was even or odd. Yeah, but we just did that, kind of. All right, so here we go, 4 out of 5. Having a piece of paper to be able to draw this would probably make it easier. Okay, and how did we do? Not very good once again. 2 people, so most people ended up going for the wrong one. Okay, we better take a look at it, see what happened. All right, yeah, tricky to work out. Okay, data is a list. Okay, that's easy. X, what's the value of X?
Isn't blue and yellow the same option?
Sorry?
The blue and
The blue and the yellow are the same option.
Oh, are they? Oh, is that? Okay, so that one I need to remember to fix. Okay, so in that case, I guess we're all right.
Yeah.
Okay, excellent. Okay, so food list A, fix. Let's see, question number 3 and question number 4. Okay. Okay, so sorry if you're unlucky and got the correct wrong answer, or the wrong correct answer. Sorry, you might not end up at the top of the day. Okay, hopefully the next one is all right. And that wasn't nearly enough time, was it? Okay, timing on this one. All right, so sorry about that one. Lots of people are going for the wrong one, though. Okay, so let's just take a quick look at this one because there is a bit of a surprise. It's really trivial, but a lot of people get mixed up by it. Okay, so first thing up is you realize, oh, it's a square bracket. So if you're making list slicing, it makes absolutely no change whatsoever, right? Okay, yeah, that's exactly what happens. It makes absolutely no difference. And there's, of course, a whole bunch of other crazy things going on because they're iterating through here, returning the length of everything. But in the end, since we're printing data and we made a copy before it went in, it's still exactly the same thing, okay, because of the slice that we ended up making. Okay, so sorry, it wasn't enough time. I'll fix that one right now. All right, so there you go. Thanks for participating, even though I had some weird problems here. In case you want to see, you can find out who's at the top, but maybe it doesn't count for anything because we didn't have a good question. We'll fix them now. List A and edit. What's the output? 20 seconds. Wow. Okay, 1 minute. Okay, thanks. Okay, and this one. Square bracket. Save.